Alright, in Learning Target 2, you are asked to evaluate relationships and function notation through substitution and by graphing. So basically the new part of this is called function notation, okay? So if you look at your note paper, function notation is a notation where a function is named with a letter and the input is shown in parentheses after the function's name. So basically what we're doing here is instead of saying y equals f of x, or y equals 2x plus 4, we're now going to usually say f of x, and that's how we say that, f of x equals 2x plus 4. The reasoning behind that is that we can say if we have multiple equations, this is mostly used when we have multiple equations, we, instead of calling this y1, y2, y3, y4, we can say f of x, or g of x, or t of x, or k of x. We can call functions different things, okay? So really just y goes away, and f of something, f of x, becomes y, okay? So then when you have something like f of 3, that means put in 3 for the input. So f of 3 would be 2 times 3 plus 4. So that would be 6 plus 4. So that would be 10. So we could write f of 3 equals 10. Because when we plug in 3, we get 10. So that would be the same as saying when x is 3, y is 10. Alright? So let's practice a little bit. We're asked to evaluate the expressions for the given values and show your work. So when we have f of 8, so we're using this equation because we have two equations here, f of x and g of x. So f of 8 would be negative 2 times 8 plus 6. So that's going to give us negative 16 plus 6. So that's going to give us negative 10. Okay? Now x, when f of x is negative 18, is basically saying what's x when y is negative 18. So we do that, we substitute just like we would have before. Instead of f of x, we write negative 18 equals negative 2x plus 6. And we solve just like we have in the first unit of this here. Minus 6 from both sides. We have negative 24 equals negative 2 times x. So I divide by a negative 2. And I have positive 12 equals x. Okay, so this would have been f of 8 equals negative 10. This would be f of 12 equals negative 18, or x equals 12. And then finally, how about g of 3? Well, I just rewrite the equation, so instead of x, I'm going to write 3 minus 1 squared plus 9. So that's going to be 2 squared plus 9. So that's going to be 4 plus 9. So that's going to be 13. So g of 3 equals 13. Alright? So that's when you're using equations. You can also do this using graphs. So not all functions have explicit rules, meaning not all functions follow the same equation. So this function would follow a couple different equations. And that's another nice thing about calling it f of x, because we couldn't call this an equation because it doesn't follow the same pattern all the time. So if we answer the question f of 4, that means when x is 4, what's y? So we go to x being 4, what's y? Well, y would be 1, so f of x, or f of 4 equals 1. F of 2 would be when x is 2. What do we get for an output? Well, that would be 4. Okay, x, when f of x is 2, that means over here, and this is f of x now. So when f of x is 2, it looks like x is 3.3 maybe, and that's not a comma, 3.3 and 6. So we have two answers there. When f of x is 5, then x is 1.3 maybe. So you can see you can do this for equations and for graphs. So why don't you try before class to answer these questions about this function. Okay, notice I call it a function instead of an equation because one equation wouldn't fit this whole thing. Try that out. All right.